This is lesson 3.1 in pre-algebra, the distributive property and algebraic expressions. And what we're going to do, we're going to start out with the distributive property. And the distributive property occurs when we have a number multiplied by a quantity of other terms, other letters, and other numbers. So what that means is, it means that we are taking 5 times this entire parenthesis, everything inside of that. Well, since we can't do it all at once, we do it one piece at a time. So we take the 5 times the x, and then the 5 times the sign and the 3. So this is 5 times x, this is 5 times positive 3. Now if I had it written like 5 times x minus 3, it would be 5 times x and 5 times negative 3. So let's look and see what happens when we do that. When we take 5 times x, we get 5x, because when you multiply a number and a letter, you just stick the two together. You can't combine them. And then I do 5 times 3, and I get 15. And what is that 15? It's positive, so that becomes 5x plus 15. Now when I do the 5 times x here, I also get 5x. But this time, when I take 5 times negative 3, I get negative 15, because a positive times a negative is a negative. And I get that. Alright, so when I have something like negative 1/4 as in example 2, and I'm multiplying it times 8x plus 12. Alright, so first of all, I take these two and multiply, and I get negative 1/4 times 8x. I'm just going to leave it there. I'm not going to actually multiply it yet. Then I take this times this. And because of that negative 1/4, I'm going to get negative 1/4 times 12. So when I multiply this through, all I can do is multiply 1/4, negative 1/4 times 8. That x just kind of hangs on there. So negative 1/4 times 8 is the same as negative 1/4 times 8 over 1. And we multiply our numerators and get negative 8. Multiply our denominators and get 4. And negative 8 over 4 is the same as negative 2. 4 goes into 8 twice, and then we have our negative. And again, we tag that x on there. So this is our answer when we multiply negative 1/4 times 8. Now let's multiply 1/4 times 12. Let's just do that up here. And let's put the negative there. We'll put the 12 over 1 again, multiply our 12 times 1 and get 12. Multiply our 4 times 1 and get 4. And we'll put that negative in front. 4 goes into 12 3 times, and that's a negative 3. So when we bring these two pieces together, we get negative 2x from here minus 3. Okay? So let's jump up to example number 3. We're going to switch gears a little bit and go in or out of the distributive property for a minute and go into combining like terms. So when we are combining like terms, that means that all of our numbers separated by a plus or minus sign like that are terms, and you can only combine things that are alike. Now, what does it mean to be alike? The letter in each term has to be the same. So I cannot combine 3x plus 4y, because this one I have an x and this one I have a y. But I have an x here and an x here. So if the letters are the same, I can combine them, and there's one other rule. Not only do the letters have to be the same, but the exponents, the little number that normally shows up here, has to be the same as well. Well, I don't have a little number here. I don't have a little number there. So you assume that it's a 1, because there is one x there. And since those numbers, my exponents are the same, and my letters are the same, I can combine those. So what I do a lot of times is I will go through and like circle this one and its sign to show what I'm going to do there. So I know I'm going to combine those. I'm going to look and say, oh, I have a 4y, so I'm going to put a box around that so I know it's different than my circled. And now I'm going to look for something that also has a y only, and that's over here. So I can combine everything in the circle. So 3x minus 2x is 1x, or just x. So I have x. I'm going to combine these two. 4y plus 2y is going to be 6y. And I don't have anything to combine the 3 with, so that's going to stay the same. And that's my answer. That's the simplified version of it. That's combining things so that it makes it easier to work with. Now if I have something like 2/3 x as an example 3, I'm going to again put a square around my like terms that have to do with the x, and notice I've got my signs there, and I'm going to circle my other like terms. There's no letters, no exponents, so I can combine those. So 2/3 x plus 1/3 x, and when you add fractions, again, you're just adding the numerator, so 2 plus 1 is 3, putting that over our denominator, 3, and then the x again just kind of tags along, and so 3 over 3 is 1, so we'll just make that an x, and then I've got negative 2 plus 7, a negative plus a positive. You take the difference between the two and put the sign of the largest number on there, and that is the answer to it when I simplify that. Now let's look at example number 4. We have negative 2 times 3y plus 4 plus 5. Alright, our PEMDAS says we're going to do everything in the parentheses first. Notice that we can't combine these because one of the terms has a letter, the letter y, and one of them does not, so we can't combine those. So our next step is multiplication. So we're going to multiply, we're going to distribute. So we're going to multiply negative 2 times 3y and get negative 6y. Remember, when you multiply, you can multiply letters and numbers. It doesn't really matter. It's just the addition and subtraction. You can't combine numbers and letters. And then negative 2 times 4 is negative 8. And then we have a plus 5. Now we have a set of terms here. I can combine these because they're numbers without any letters. The 6y, or negative 6y, there's nothing to combine it with. So negative 8 plus 5, signs are different. Take the difference between the two, put the sign of the largest number, and we call that good. Alright, I will continue on the B as in boy version of 3.1, and we'll do example 4.